You guessed it, we're back in the topic of CMake. Roll the intro. You just gotta create a branch and get on with it. This series has been a collection of topics about CMake to make it a tool that goes from working against you into one that works for you. For many of us, find package in CMake is a command that's big and scary. Now, I hope in today's video that we can demystify it a little bit and turn it into a powerful tool you can wield in your projects. CMake has the ability to go find packages out on the system and import them into your project so you can use them. The vast majority of the time, this ends up being libraries, but other executables and resources can be included too. Most of the discussion today will be about libraries, but just know that the concepts will generalize. They're universal. So here we are, looking at some code, going to look at find package. Now, to get started, maybe it's good to say a few words on what's the point. Why are we looking at find package at all? And it's to get targets that are outside my project imported into my project, and then you can use them. So we're going to look through this little example right now, which is a little kind of hello world program. I work on a project called Osprey. It's a rendering library. Here's a little hello world program of Osprey that sets up a little programmatic mesh. The details of that aren't super important. The key is that if I have Osprey somewhere on my system installed, that I can go get it, make sure a particular version requirement is met, and if so, CMake will succeed and give me this target. Now, there's a lot of details for how projects export a target, and we're going to go over that in a later video, not today. Today, we're going to look at consuming packages that are found on the system. And so my last video in the series talked about what targets are. So this executable target's the only one we're building in this example, and there's different properties that come with targets. And so the idea is there can be those same properties attached to libraries and other resources on the system that come into existence for this app called OSP tutorial to build against. And that's what this target does. So like all things in CMake and C++ and programming in general, it's good to look at the manual and look at examples to learn how they work. So I am a big fan of Kitware's documentation of CMake, so we can have just a little look at the find package signature. And what's great is the latest documentation splits into a simplified, like most common use case to get kind of this is the most of the time what you're going to encounter. And then here's the actual interface of everything find package can do, and it's a ton of stuff. And so we're not going to cover all those details today. The idea is with the basic usage, you can get a lot work done. And then once you have all of that, you can start to explore the more complicated stuff. And again, not get too attached to the complicated stuff, but when there are those times that you have some crazy setup that you need, find package probably can do some stuff for you, which is great. So the way find package works is it's a command, like you saw in the example code, that you have a particular package you're interested in, and then everything after that is optional. So this is the only required argument. You can provide a version and say if it needs to be exact or not. So you saw there was Osprey 2.0.0. What that'll be is as long as the major version is the same, then you'll need that minimum version or greater for this find package to succeed. So if it finds something that's older, it will fail. Or if you provide exact, if it doesn't exactly match this version, it'll also fail. Required says if this fails, CMake fails. So there's plenty of places where you find package, and if you can't find something on the system, maybe some feature gets turned off or you don't build with that dependency. And so required says if this find package fails, it is fatal to CMake being able to succeed on the project you're trying to build. And quiet is kind of like the inverse, but not quite. So it's optional. Quiet says it's optional, and if it fails, we're not going to have any output at all. And this is a common option if you have maybe a copy of a dependency, or you want to use fetch content or something to satisfy a dependency, but you would rather prefer the system first. What you can do is find package, quiet, determine, hey, was the thing found that I was interested in, package name. and then make decisions off that. And you don't need to muddy up the CMake output with, hey, this failed, what's going on? This will just transparently do that behind the scenes, and then your CMake code can still make decisions on if this was found or not. We're going to talk about finding configs versus modules, and so modules attached to that. I guess the other thing I'll mention about components in general is some packages, depending on whether they're modules for how do you teach CMake how to go find something. That's what a module is you say, hey, CMake, this is how you go find dependency X. Sometimes modules or even configs will be subdivided into smaller components. So like Qt and Boost and other really large projects. So it'd be like, I want to find Boost. Well, what parts of Boost do you care about? Because there's a lot of libraries within Boost. Components is a way to let a package subdivide itself without making you do lots of individual find packages. So you could list them all at once. And then, of course, all of these things apply to components as well. So this documentation says a lot of that. So hopefully if that's somewhat making sense to you, everything that I just mentioned, then hopefully that'll make this a little easier to read. So the next thing is to distinguish between an imported target versus a normal target. By convention and by CMake really encouraging it, modern CMake I'll say, and CMake 3, that there's this is still just a single string, but the namespace syntax is a way for CMake to know, oh, this package exported this target. And so this convention helps commands like target link libraries know that this should have been imported. Because remember, back in the video that talked about targets, target link libraries can take raw library files on your system. And so it may not know that this is a target. Like if it was just this actually might be osprey.so, and then CMake will try to put that on the link line. But this namespace syntax indicates that this was imported. So if like I didn't have required here and this failed, this is a way that CMake could be like, looks like there was an imported target that didn't get satisfied. Are you sure that's what you wanted? So that's an error warning message you'll see sometimes. But an imported target is one that is different because this target name CMake knows doesn't have to be built somewhere else in this CMake tree. And so but otherwise it's just a target that behaves like other targets that we built here locally, like this executable target, or if we had some directory that built a little shared or static library, that would be a target, and then we would link it here. So this is all fine and dandy. However, find package is when it fails, that's when people kind of get nervous. And there's two concepts for us to consider. There's find package configs and find package modules. So we're going to start with configs. Now, if I open up a terminal here, somewhere on my machine, I have a custom installation of Osprey and all of its dependencies in one directory called RenderKit. And I usually do this in home opt. So if I go to opt, I have some stuff installed on my machine here. This is just in my home directory. This is not standard. So this is not user local. This is not /user. That's like what your package manager is doing. But for me, my setup of my machine, this is what I like to do. So find package is going to look in default places like user local by default. On Windows, I forget what the rules are. You can go look it up in the documentation. I'm a Linux guy. But the point being is the standard locations, CMake knows how to go find stuff. So everything else is about, hey, I want to have find package find something, and I need to tell CMake where that is. So we'll get there, but what are we looking for is the key, because the package, find package is actually looking for CMake configs, not the actual files themselves. That's what modules do. But with a config, I did a make install of Embry, Open Image Denoise, some OpenVKL stuff, Osprey stuff. There's TBB in here. The point being is this is actually multiple projects all installed in one directory in opt RenderKit. Under this, there are also some CMake configs, which, let's go to Osprey, that there are these named files that are named this very intentionally to say that this package, all of its exported information, I built Osprey, and Osprey's build system, because it's built with CMake, we have it export certain targets, that then downstream projects like this one can then link. And so that's contained in this Osprey config. What happens is find package will go and look for this file. So if it's in like user local lib CMake or user share CMake, like there's some standard paths in that documentation. It'll say where it's looking. It's still looking for this file. Just because it's in a non-standard place on my machine doesn't mean that it is inherently any different. There's multiple ways we can point find package to get to this file name, but just know that when you are looking for a project that exports targets, this is what we're looking for. Like all this other stuff in here is included in this. So this is the thing it's looking for. It's package and then capital C config.cmake. And this package name exactly, even case, I think matching what is in find package. So all of the RenderKit projects have this, and there's plenty of projects out there that export targets. And so CMake knows to look under lib CMake, whether it's on your system or somewhere else. And again, we'll get to how to point that, but just know that's what we're looking for. So that means, how did we do that? We'll get there, but modules are then what are different from configs. So I'm going to go over here to my little cycles viewer that I think I used in a previous video. We can just close all this stuff, so we don't need it. Here's what a module is. Notice that this find something, this is now find and then a package name. So if I need to find package cycles here, and that's capital C cycles. To use a find package module means that, hey, find package didn't have it didn't find a config in any of the places it was looking for. So now it's got to go find a module to say, hey, is there CMake around here somewhere that has taught me CMake how to go find this thing called cycles? And at the end of the day, it's kind of similar, but in the result, but a very different mechanism. So configs are, say, here are the targets, the libraries, like executables, even, all those properties associated with those libraries. Here are the targets that come into existence. A module is trying to make targets based on library files it finds, include headers, etc., anything else. And so, I started, there's actually a find package module that Tangent Animation had in their Hydra cycles delegate, HD cycles, and I took it and extended it to create a target. Because at the end of the day, creating a target, whether you find a config or use a find package module, you should be making targets. And so what I do here is I took all the stuff they did before, which was, hey, we're going to go find some stuff, and maybe in a later episode we'll talk about like how to write one of these things like really effectively. But we look for some include directories, look for some library files. We look for some library files, look for in particular places from some root. Anyway, at the end of the day, there's this imported library target that gets created. And then this library target carries all of the link dependencies, the include directories, all the compile definitions necessary. So that means in the app itself, so somewhere there's a target here that links cycles. And all of those things, the include directories, the libraries, preprocessor definitions, all that stuff is now encapsulated in this target, and all of that information is then propagated down local targets I'm building in this project. So this little interface library I have that then gets linked into another interface target that then gets linked in the app. All of that information is propagated according to these target link libraries. So what that means is my app, because it linked this and this linked cycles, I'm not scrambling here to figure out, like, do I have the right cycles include directories and the preprocessor definitions and all that? No, you just link a target and that's it. Everything propagates. So with this module, that's exactly what we do. We make sure we find all of the things on the system necessary to satisfy that. And then there's a standard way to say, hey, did you find everything? And if you did, so if we found, because this is a standard output of, again, we'll talk about those details in another episode. But anyway, if we found the things we need to find, we wrap it all up in a target, and then away you go. So if we go back to this little example, we can talk about, hey, what happens when this is in a non-standard place? Well, let's go to my build directory, and let's just start afresh. So let's CMake this project. There are some warnings because I've messed stuff up in Osprey. But the point being is, how on earth did this find Osprey in the right place? There's multiple places to do this. Now I'm going to unset CMake. I'm going to make sure my magic stuff is out, and let's just start again. Yes, and now let's CMake. This should fail. Yes. So this is the message that trips up so many people. We did a find package Osprey, and in all the standard places on the machine, like, it didn't show up. There was no Osprey to be found. And this config is what we're looking for. Now, it's your project, your downstream project, or upstream project, I forget which direction we're talking about Osprey here. Osprey ideally should export its targets. And in the documentation, we tell you, hey, yeah, we do this. So find package, go find our Osprey config. It's in the standard place under lib, CMake, Osprey, and version, all that stuff. This we export to you. And so remember, there's both modules and configs. We don't have locally a module that knows how to go find Osprey. And so we got to point find package at the config. There's multiple ways we can do this. It even tells you here how to do it. So you can actually take the prefix of Osprey and put it on CMake prefix path. This is a concatenated path, kind of like LD library path. Can take paths and add non-standard locations to them. So if I export grep CMake prefix path, nothing there. We have nothing in no environment variable set. Anyway, we can just add it to prefix path, or you can take individual projects and point them individually with a variable, which is the package name underbar dir, which is the directory to where this is. Both of these things we can set both as environment variables and as CMake variables. We can fill out, so if we bring that message up again, we can find this with a CMake variable. We could say CMake-d osprey dir equals opt render kit libs CMake Osprey 2.4.0, and we have found Osprey. Now we have to go, because Osprey needs Embry, it does find dependency Embry, and we could do this for individual projects, or we can use CMake prefix path. If I start over, and let's say, just so you know, to finish the last thought, you could also export Osprey dir equals and then the same location. But CMake prefix path is pretty powerful. And so what I'm actually going to do is just reset my terminal, which gets me to talk about something else, which is the environment. So I do export grep CMake prefix path. This is something, because I have in my system, my personal organizational system is to put installation of particular projects in home opt and then name of project. Heavily use your bash RC, or Z shell RC, or whatever your login config file is for your shell that you use. Have this set every time. One thing I find very interesting, people get really annoyed at oh man, I had to specify all these paths. Well, if you're going to do it all the time, just put it in your bash RC. But CMake prefix path is great because, you could also have a colon and then more paths. So I only need one here. But what's nice is, let's see if I'm clear here. Yep. So if I run CMake now again, the reason this succeeds is because CMake prefix path is going to go look for all of those configs, but CMake prefix path only needs that lib CMake directory. So if I go to opt render kit lib, you'll notice there's a CMake directory in lib. This is all in that documentation. You should read it if you really want to know these details, but just know that each one of these directories is, so if I look in ls, if I look at Embry, there's the Embry config. Open image denoise is the open image denoise config. We looked at the Osprey one. All these configs are in there. So when we say Osprey dir, we're only going to be looking for the Osprey. We have to have a path to Osprey only. Versus CMake prefix path will say, well, give me the prefix to where all the projects will be. And then it knows to look in a directory that's just Osprey, and then optionally Osprey with version information if we wanted to have more than one version of Osprey, here installed in under RenderKit. Just know that CMake knows how to differentiate all those things. And so you can use CMake prefix path to where all of your configs are. And this could be CMake prefix path. There's multiple places. Like I could install all these projects in their own standalone directories, put all of their CMake, their lib CMake directories on CMake prefix path, and then I'd have the same output of being able to CMake, and it knows how to find this stuff. It found OpenVKL, found Embry, found Osprey, found all this stuff. So again, that's a config. So if I unset CMake prefix path and I go and build all over again, this config isn't local. Or sorry, this module isn't local, and this config needs to be found. That's what find package, when it fails, this is what it's failing on. You'll also find that if you had components in here, like find package boost, and you had a bunch of boost libraries, but you didn't build the right ones you were looking for with find package, then of course you get a similar looking message, but it said, hey, I found these components, but I didn't find these components, and you told me you had to. But that's the basics of what we're going for. Is we're looking if we don't have a module local that is find Osprey, then we got to have a config. And if we don't have a config, this either fails, or what I could optionally do is this. So I could then CMake, and it still is now a warning because it's no longer required. We still get the same output, but it succeeded. But then here's that message I was talking about with the missing target, because of that colon in there. CMake's like, that's probably not a library, a shared object library, or a static library that needs to be added to the link line. So this is probably a target. And so because this wasn't satisfied, this target didn't show up because this failed. Is this missing? Yes, it is, because look, it was missed. So that's the basic mechanics for how this works. You know, use CMake prefix path, or have individual project underbar dirs in your bash RC to let your environment be friendly. And again, that's all if you want to have non-standard installations. I'm a big fan of having things like a walled off op directory here, because I could blow away RenderKit and I don't have to go into like user local lib and figure out what are the individual libraries I can safely remove and all like the headers, and like I can just say, hey, that's my installation route, and I can blow it away, replace it, upgrade it, whatever, and it's trivial to do that. That's my personal workflow. Just take that for what it's worth. So that's it for today. CMake find package has a lot in there going on, but if you look at it piece by piece, it's not so bad. It can be something that's very valuable and helpful. If you enjoyed this video, hit like and subscribe. And let me know down in the comments if there's a topic about CMake you want to hear about. There's a lot we could talk about, so I want to make sure it's tailored for you out there. And until next time, happy coding, everyone.